What's happening, people? Pastic here. We are going to talk about in this video finding limits of exponential functions, and I'm going to do that in a couple of different ways. The first way I'm going to do that is by using my knowledge of exponential functions in general, how they look, and transformations of functions. So, first thing I'm going to do with this first function on number 5, which is e to the negative x minus 1 power plus 2, we're finding the limit as x approaches infinity. So I'm just going to walk through what I see. I see a base of e. So a base of e initially tells me that we've got some sort of exponential growth function that looks like that. Then I've got a negative exponent, negative x minus 1. Just to rewrite, this kind of looks something like this as well. Infinity, I can rewrite the exponent as negative x plus 1. So that further gives me an idea that my exponent is indeed negative. So once I know the exponent is negative, that's an inside change. We're affecting the independent variable, which is x, and we're reflecting it. We're multiplying it by a negative, which is reflection across the y-axis. So knowledge of this negative exponent tells me now that my graph looks like more like this. A reflection across the y-axis. So now what I'm looking at is exponential decay. Well, the only other thing that I see is a shift of up 2. So in the end, this is a pretty good idea of what this graph hopefully looks like. So I'm going to now take a look at what I'm going after. I'm going after limit as x approaches negative infinity. So if I follow this graph that I've just created towards negative infinity, I'm going this way. It looks very much to me like this graph is indeed going towards positive infinity. So that should be the limit. So again, as I'm going towards negative infinity on the x-axis, these y values are trending upward very, very rapidly towards positive infinity. So I believe that's what our limit should be. So I want to verify that. Well, to verify a limit as I'm approaching negative infinity, I'm just going to pick a very large number and plug it in. And by very large, I mean very negative and large. So something like a negative 1,000. So I'm going to just try it. Let's just plug in e to the negative 1,000 plus 2. Oops, that should be done here. Minus 1 plus 2. So that turns into negative 1,000. So e to the 1,000 minus 1 is e to the 999 plus 2. And if you know how to calculate that at all, I mean, you don't even have to calculate it. You know, you're taking a 2.78, which is e, or 2.718, which is e, and raising it to a very, very large number. We know that we're going to get a very, very large output, which again further indicates that the limit is growing towards positive infinity. Keep in mind, that's not an actual limit. That's a limiting behavior, but there actually is no limit. So the best answer, again, is does not exist. But for most problems, you're going to be okay by putting positive infinity. So let's try one more of these. Maybe let's try 6, just because it's slightly different. So the first thing I notice on number 6 is that we're taking the limit as x approaches infinity of negative 0.4 to the x. So on this one, I'm noticing the base is 0.4, which is 2/5, which is between 0 and 1, which indicates initially, without other changes, we've got exponential decay. Well, then I've got a negative on the outside. Well, that's an outside change. That's not going to be a horizontal reflection. That's going to be a vertical reflection. So this function that was exponential decay is now something that looks like this. More like a logarithmic function almost. The only other thing I see is a shift downward of negative 4. So essentially my end result of this function should be something like this, with negative 4 being right here. And that's just from analyzing the function. So, based off of that, and again, I said it kind of looks like a logarithmic function. It is not a logarithmic function. The behavior on the left side of this is very different from a logarithm. But it kind of, just in my drawing, sort of looks like one. So now I want to, it looks like if I'm taking the limit as x approaches infinity, I'm heading over in this direction. And what are my values doing? It looks like they're getting pretty flat over here and approaching -4, which is our horizontal asymptote. So let's give a quick numerical check to see if that makes sense. So positive infinity, plug in a very large number, -0.4 to the 1000 minus 4. .4 to the 1000 is 2/5 to the 1000th power, is basically 0. Put a negative on it, you have basically still 0. So this is all essentially 0. So what do we have? We have -4, and that should be indeed our limit. So let's just be a little bit more formal in the final answer. Limit as x approaches infinity, which I can't make a nice infinity symbol, of -0.4 to the x minus 4 does indeed equal -4. The last thing I'll say is, in the end, if you do these in one of these two manners, what else should you do? Well, when you're at home practicing or you're in class and you're not taking a test or anything like that, plug the equation into your calculator and see if the limit makes sense. Get a visual representation that you know matches the function at hand. And that will verify or corroborate what we thought the graph might look like. So that's finding limits of exponential functions in a nutshell. Catch y'all next time. Take care.